Hey, what is good, everybody? Welcome back to the channel. In today's video, we're gonna be talking about something that is rarely talked about in the macOS community, especially for those guys who are coding the applications in C. So let's say you have an application, right? Right now, I have an app called App. So let me just run it real quick. It's a console application. It prints out hello from plugin for every frame that is basically running here. So if I just cancel this out and close this application, you can see that it's basically just console outputting hello plugin, right? Hello from plugin, right? But then let's say you develop this app even further and you made it possible to actually display a window and all of that stuff, which basically I have done right here. Essentially, I have my own library which basically builds a window for me. It's similar to GFW, but it's my own. It's Mac specific, since we don't really have Mac specific stuff for C or C++ programmers. So I just decided to make my own library for window handling on a Mac OS operating system. If you guys are interested in this, I do have a blog coming on in relation to this GLFW inspired Mac window layer, right? But yeah, so I developed this application further and it now shows a window. So let's say now I want to basically build this up, and not in the form of a console application, but in the form of an actual application, right? So that it can have an icon like Quick Player here, Sea Lion, Key Access Keychain, and all these other applications that you see down here, right? How do I do that? Well, for macOS developers, well, essentially you have to create an app bundle. I believe it's called an app bundle. I'm still not entirely convinced if it's an app bundle, but if it is, give me a thumbs up. But it's an app bundle, and essentially what an app bundle is if you look at this, right, this is the executable that I have basically bundled up to look like an application. And if you guys can see, you'll see some metadata: created when, modified when, last opened when, and the version number, right? So you want your executable to actually have something like this. So how do you do that? So essentially what you have to do is create an app bundle. So an app bundle, in order to understand what it is, essentially it's just a folder that has other folders within, and one of those folders actually has your executable within. It's just how Mac OS handles applications. So you can think of it as an application, essentially, with all of its frameworks and libraries all bundled up in separate folders and resources and all of that stuff, right? So here it's composed out of an info plist, which is very important for an app bundle. This is basically describes your metadata for your application, which is also the information that you see here. So if I go back, right, if I click on my app bundle here, let me just do this, right? You'll see this metadata here, right? The version number and all of that. Your info playlist essentially just gives the operating system that information about your application, your executable, and all of that stuff, right? So you need one, and you also need, if you guys have seen a code signature here, it means that my app has been code signed with my developer's ID, team ID, just so that it's more authentic and all of that, and it can basically prevent people from impersonating your libraries, especially if your application makes use of dynamic libraries. If you code sign your dynamic libraries and your application, then it's possible that no one can essentially hack your application by basically creating another library which has the same name as your dynamic library and then just flipping them up or switching them out and basically hacking your application. That's not possible if you actually co-sign your application. It just protects you from those type of attacks. I believe I'm not really that technical in terms of security and all of that stuff, but just know that co-signing just protects your application and your libraries and all of that good stuff. And it's also required anyway by Apple if you are going to basically distribute your application and all of that to the App Store. You just have to co-sign your application. So yeah, it essentially composes out of these folders, and these folders, essentially the frameworks folder holds all your dynamic libraries or libraries that your application makes use of, and then your macOS essentially just holds the app executable, your actual application. And using an app.ds SYM, which is essentially just the debug symbols from my application. Since this is still in debug mode, it's not in a release build. It's not a release build, so it basically still has them debug symbols in it. And then you have a resource folder. Essentially, this is where your icons for your application will go through, or your assets that are used in your game engine or your game or whatever. They'll go into this folder right here, and you can access that through your application. as how you please. So yeah, how do I do this and how did I get to this point? It's very simple actually. If you think about it, all you have to do is just create a folder that has contents in it, and then it has these folders in it, and then in those folders you just put in your executable in the macOS folder, and then all your libraries just go into the frameworks folder, and that's essentially it. If you have icons, you just put them in the resource folder. It's just that. It's just a folder management system, I guess, if you just simplify it. Yeah, so how did I do it? So let's get into the code. The code is very simple, essentially. So this is my application. It's actually making use of my own windowing system to actually show the window. So if I just give you a demo real quick, if I just run this, let me just get out of the package contents for this app. Let's go back. Yeah, here we go, engine.a. So if I double click on my app, right, it will open it up, and if you go down here, you'll see that it has this icon placeholder. That's because I don't really have an icon for my app yet. And then you can see that it gives my my app's name, which is engine A. It's just a test name. It's not really the name of my engine. And then you have your application right here. So this behaves like a real application. It's no longer a console application as it was originally. It's now an application, an MS application. And that's because now it's bundled up, right? And we have an info plist to actually give it some descriptions and all of that stuff. So how did I do that? The way that I did it essentially is that if you go down to my app, my bundle folder here, it actually has those folders that I just showed you, and then it has the info plist. Now this info plist is the most important part of it all, because it's some metadata that describes your application, how it was compiled, what compilers make using of, and all of that stuff, right? However, I don't think you need this. For me, I just put them there just so that I can test it out, but then you do need some of them just so that the operating system knows more about your application. Yeah, some of these are optional, some of them are pretty much needed, but then yeah, just keep that in mind, okay? You'll do your own research on how an info plist actually works, and just to get a better understanding of how things are. Okay, so we need to generate an info plist. I have a C program here that actually generates that for me automatically. It's still, everything here that you see is still hard-coded, but in the future I'll be modifying it so that I can actually be more dynamic. All I can do is just pass it in a configuration file, and it will just build a plist for an app that I want to build for production. All right, so for now everything is just hard-coded, but you guys can just basically copy paste this and experiment with it on your own. It generates an info plist for me, and it basically puts it in my app bundle, and then my make file handles the building of my library, and then it just puts it in the in my frameworks folder of my bundle. And then I have the client here, which then basically builds my client and then puts it in the macOS folder, and essentially that is it. And this one right here is just to build out my info plist generator, which is just a C file, which I just showed you guys generates a plist for me. And then from there, that is essentially it, right? And how you get this code signature thing, you have to essentially code sign your application, and you can do that using a command on the console called code sign, and then there's some things that you have to pass in, some attributes and all of that stuff. You can just Google it. It's pretty simple to use, but I won't cover this in that video because it's not really a coding video. It's just for me to show you guys how things are actually working here while I basically created my own app bundles. So yeah, this is it. That's essentially just how an app bundle is created, and this is my workflow. Essentially everything is just automated within my makefile script, so it's not really a lot of work. All you need to do is just describe these folders here for your app bundle like I did here. You could have just simplified this, but I just did it step by step so that I can know how many folders I'm creating and where they are, and I can basically reference them downwards here in the future by the time I basically add more things to my makefile, so that I can put things in the resource file paths and all of that stuff, right? So yeah, that's essentially it. If you guys want to learn more about this, I will definitely make a blog post about this, detailing some of the steps that I did and some of the decision makings that I took to essentially get to this point. But yeah, it's really trivial to actually understand how building for macOS actually works, especially if you're a C developer and you're not really making use of VSCode. you really need to understand most of these things. That will really make you very good at what you do, especially when it comes to these low level stuff that are basically just easy to basically get done and dusted with. It's really not a difficult thing. But I just wanted to share this with you guys because honestly, I had a tough time finding help on how this actually all works. There are some I gotchas as well involved here, especially if you're using dynamic loaded libraries like I am. However, I got it working, but I won't cover this in this video because it's beyond the scope of this video actually. But in my blog post, I'll definitely cover up how I handle dynamic loaded libraries, and how to tell the operating system where to look for them and all of that stuff, right? So yeah, that is it for this video. Thank you guys for watching, and I'll see you guys in the next one. Cheers.